If you're watching this, you're probably on your phone or your computer. If you're watching this on your Samsung fridge, you're a weirdo. Either way, you're probably using Wi-Fi to stream this video off the internet. What is Wi-Fi? Wi-Fi stands for Wireless Fidelity, a term interchangeable with WLAN, which stands for Wireless Local Area Network. Basically, this means that all the devices in your home are on the same private network, a network referred to as the intranet. So, this intranet connects all the devices in your home together, and the internet connects all the devices in the world together. Well, what if I told you this wasn't even an original idea? A dude called God already had this idea trillions of years ago when he was making this really bad game called the universe. Instead of phones and computers, he uses atoms. Instead of a home, this group of atoms is called a molecule, and the forces that connect these atoms are called intramolecular forces. Intra referring to the fact that the forces are within the molecule. Some examples of intramolecular forces are ionic bonds, covalent bonds, and metallic bonds. These determine the name and shape of the actual molecule itself. But what about the forces between molecules? What if this atom wants to bond with this atom? Well, these forces are called intermolecular forces, and in general, they're a lot weaker than intramolecular forces. Intermolecular forces don't affect the molecule itself, but they do affect how attracted each molecule is to the other. These attractions are very much like real attractions between actual people. Much like in real life, there are different levels of attraction. Starting from the weakest, we have van der Waals dispersion forces, which is like the attraction between ugly people. They like each other, but only because they can't get any better. Molecules with this kind of bonding are called nonpolar. Then we have dipole-dipole bonding, which is like the attraction between two regular human people. Molecules with this type of bonding are called polar. Then we have hydrogen bonding, which is like the attraction between Henry Cavill and Margot Robbie. Now, if you're above the age of 7, you probably know that the more packed together the molecules are, the more solid the molecule becomes. So the attraction between molecules is what determines whether something will be a gas, liquid, or solid at any given temperature. For example, the molecule methane is an ugly person. It's not very attractive, and so when you put a bunch of them in a room, they tend to stay apart. In chemical terms, methane only exhibits dispersion forces between its molecules, and so its molecules are not attracted to each other, resulting in a much lower boiling point. But water is like Margot Robbie. She is very attractive, and so if you put a bunch of Margot Robbies in a room, they would stay packed together. God, I wish I could be in that room. In chemical terms, water exhibits hydrogen bonding between its molecules, so they are very closely packed, resulting in a much higher boiling point. Another thing that intermolecular forces determine is solubility. When we talk about solubility, we are usually talking about one type of molecule dissolving in another, unlike in boiling point when we are talking about the same molecule. Always remember the rule that like dissolves like. Ugly people will be with ugly people, and Margot Robbies will be with Margot Robbies. Basically, non-polar molecules will only dissolve in non-polar molecules, and polar molecules will only dissolve in polar molecules. I've sometimes been asked by my students, why can't something like methane dissolve in water? Surely since water has hydrogen bonding, it should be able to attract methane. What ugly guy would reject Margot Robbie? The answer to that is Margot Robbie would never settle for an ugly guy. There are two specific things that need to be achieved for every dissolution: breaking the bond and replacing the bond. Non-polar molecules have very weak forces of attraction with each other. This means that another non-polar molecule can rock up on this couple and break them apart easily. It can then form its own bond with this molecule and voila, dissolution. If the same non-polar molecule were to approach a pair of Margot Robbies, it would not be able to break the strong bond between them, and so it won't be able to dissolve. So basically, the hydrogen bonds between water are just too strong for something like methane to break them apart and dissolve with it. So, to recount, we've learnt that intermolecular forces of attraction determine things like boiling point and solubility of certain chemicals. We also learnt that most ugly people won't be able to get in with Margot Robbie. In the next video, we'll talk about what makes a molecule attractive. And sadly for Margot Robbie, we're going to learn it's not about how pretty you are, it's what's inside that matters the most.